Okay, year 8, welcome to your video tutorial. Today we are going to be having a look at index laws for multiplying and dividing. Okay, we know that y, if I have something that's written y to the power of 2, that just means y times y. So y to the power of 3 must be y times y times y. The thing that we call the to the power ofs, okay, to the power of 2 squared or to the power of 3 cubed, we actually call that index notation. And basically it's a super easy and convenient way for us to represent repeated multiplication. So rather than writing y times y times y, we write y to the power of 3. And besides from writing y times y, we write y to the power of 2. So we use this thing called index notation in order to make our life a little bit simple. Now, today we're going to have a look at how we multiply with indices, okay, or with index notation. And we've got 3 examples for multiplying, and we're also going to look at 2 different examples for dividing. Let's have a look at this. You'll need to write this down. And it says simplify the following using the index law for multiplication. Now you'll notice that my base numbers here are the same. 5 to the power of 3 times 5 to the power of 4. Okay. When I'm simplifying this, I keep my bases the same. My base doesn't change. So it stays as 5. Now, I've got 2 to the power of 3 and then 2 to the power of 4. Okay, and they're the indices, they're not the bases, so I'm not exactly directly multiplying those. My quick trick, if I want to simplify them, and I have the same base, I simply add. Okay, so I've added 3 and 4 together, so 5 to the power of 3 times 5 to the power of 4 can be simplified to 5 to the power of 7. So if my bases are the same, I simply add the indices. Let's look at this example here, 5 to the power of 3 times 5 to the power of 7 times 5 to the power of 2. Okay, bases are all 5, so I leave that the same. Then I've got 3 plus 7 plus 2, which becomes 5 to the power of 12. I can say 5 to the power of 3 times 5 to the power of 7 times 5 to the power of 2, or I can simply say 5 to the power of 12. This next example, what looks different about this? Well, I noticed that my middle number 6 here doesn't have any to the power ofs. What does it mean when it doesn't have a number there? How many times am I multiplying it? Well, I'm multiplying it once. So I always like, when I'm doing these questions, to write that 1 in. Like I sometimes write a 1 in front of a pronumeral because it just represents 1 of itself. So this time my bases are all the same, so I'll put a 6 on my base and it will be 5 plus 1 plus 3. So that's 5, 6, 7, 8, 9. 6 to the power of 9. Okay, so when I'm multiplying, I add the indices. Going with that logic, this question is dividing. If when I multiply, I add the indices, what do you reckon I do when I divide them? I'm hoping some of you are sitting there going, subtract, subtract, subtract. And if you are, that will be right. Let me exactly show you what this is saying. 5 to the power of 7 is saying 1, 2, 3, 4, 5, 6, 7, over 5, 1, 2, 3. Okay, for every 1 I have on the top, I can cancel it with 1 on the bottom. For 1 I have on the top, 1 on the bottom, 1 I have on the top, 1 I have on the bottom. What am I left with on the top? 1, 2, 3, 4, and I've got nothing on the bottom, so it's going to be 5 to the power of 4. Oh, hold on. Do I see a relationship between 5 to the power of 4 and 5 to the power of 7 divided by 5 to the power of 3? Could I have got that in a simpler way without having to draw all this out every time? 5 to the power of 7 divided by 5 to the power of 3. Give me an answer of 5 to the power of 4. Again, I'm hoping some of you are sitting there going, subtract. Subtract, miss. When I've got division and I've got a base that are both the same, so these are both 5 in this case, these big base numbers, okay, I can simply subtract my indices. 7 minus 3 is 4. Let's have a look at this example. Simplify the following using the index law for division. Now my 6 will come out because that'll be the base is the same. 20 minus 5 becomes 15. Don't believe me? All you can do to check and see if you're right is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and if you really, really want, you can check and see if I'm right by cancelling them out. 1, 2, 3, 4, 5. All I'm doing is expanding the 5 there and the 20 there. And I can take 1 for 1. 1, 2, 3, 4, 5. And I am left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, if you don't believe me, check and see for yourself. But when I'm dividing, okay, I take the original indice and I subtract if the bases are the same. When I'm multiplying, I add. And that's it, guys. That's index laws for multiplying and dividing.